Hey everybody, Mr. Holmes here, and what I would like to do is just a quick demonstration on sediment deposition. And you may remember that sediment is fine particles like sand and mud and things like that. And this water sample I have had for 8 years or so. What this comes from the Elwha River in northwestern Washington state, part of the Olympic Peninsula, which is near the Olympic National Forest, and I'll include some pictures here for you in a little bit. But basically, the reason why I grabbed this water sample is that at the time that I had visited with my family, and this was in 2012, there was a lot of sediment in the river. And basically a background on the Elwha River is that in the early 1900s, electricity was needed and a couple of dams were put in on that river. And the unfortunate thing is that there was a lot of wildlife, including salmon, that would use that river. The salmon would swim up that river to spawn and make more salmon and everything else. Well, when humans came around and dammed it up to generate electricity, basically that blocked off the river, and so salmon couldn't get past that dam. And there was an effort in, starting in the 1990s to try to get the dam taken down. And in 2011 is when the dam removal actually started. And so when my family was visiting on vacation to go check out that whole area, we had camped next to this river, and the river was super cloudy. And what it was is, back above the dam, there would still be rain and erosion and mud and everything else that was, piling up behind this dam. And there was a lot of sediment that was behind that. So when they eventually took the dam down, it took about 5 years for the sediment to be fully washed out and washed downstream and go into the ocean. And so now the river does not have a dam. It is flowing nice and clear and everything. But when we went out camping, I grabbed a spare water bottle and just dipped it in the river, and I picked this up. So this is Elwha River water that I have had since 2012, and you'll see there's a little layer of sediment here at the bottom. So what I'm going to do is do a time-lapse video to show you how this sediment deposits down to the bottom. Obviously, gravity is going to play, a key role here in terms of the particles settling down. So I'll go ahead and shake this up. I'm going to do a time-lapse video, and we'll see how long it takes for it to get back to this state. Okay, so I'm going to go ahead and shake this stuff up, and then we'll do some time-lapse. All right. So here is the flood. Here is the draining of the river. This is what it looked like when I grabbed that water sample. All right, so this is the time-lapse part, and I kept the camera going for about 2 hours, and it does take a long time for all of the particles in this water to settle out to the bottom of the jar. But one thing I want you to think about is gravity, as well as maybe the resistance or the bumping into water molecules and things that these particles have to encounter on their way down, and how that affects the particle size when these layers are forming. Obviously, with the water churning in the river, it keeps these particles stirred about, and it's kind of mucky and thick and brown. But once you get to calmer water, like in this jar, then everything starts to settle down, and all of these particles are getting sucked down closer to the planet Earth just as a result of gravity. By the way, here's a picture of the Elwha River pouring into a larger body of water, and you can see all that sediment that is being carried out into the water. Okay, now we're at the super boring part where we're just waiting for the most tiny particles to sink to the bottom. So this is where it takes a lot of time, and I'm just going to kind of skip over things for a little bit for now. Okay, so here we are. This is 24 hours later, and you can still see a little bit of cloudiness, but these are just the smallest, finest particles that are still on their way sinking to the bottom. But I wanted to zoom in a little bit, so the next image I'm going to share with you is kind of zooming in to the bottom layers of this bottle. Okay, so as we're wrapping this stuff up, I just wanted to zoom in a little bit on the sediment that has piled up at the bottom of this jar, and I'm actually going to zoom in just a little bit closer with a cell phone photo, and you'll be able to see that the larger particles settle down to the bottom first, and then they've gotten covered up by medium-sized particles and then smaller particles, and the super teeny tiniest stuff is settled down there at the bottom. So ultimately, if this were buried by even more rock and more sediment, the weight could actually cement it together as actual sedimentary rock. But in this jar, there's no pressure on it or anything, and so it's just going to stay as little tiny particles in the jar. Last thing I wanted to do is there was actually a layer of mud you could probably see up at the top, and I wanted to show you what happens when I tilt it. And you can see it separating, so that may be more organic material as well. So hope you've enjoyed this. Have a good one.